Hello everyone. Am I audible? Yes, thank you. So last week, some of the students have asked for another live session. So from this week, we are going to do two live sessions per week: Tuesday 5 to 6 and Thursday 5 to 6. And if you have any queries, discussions, and if you have any doubts, you can ask during Tuesday. The problem solving is scheduled on Thursday, but it's not going to be very strict, like doubts only be done on Tuesday, Thursday only problem solving, not like that, but most of the things will be focused like this. Okay, so utilize your Tuesdays to solve all your doubts, whatever you have questions in your assignments and all. And we find little difficult to navigate the discourse all the time. We are there, we will answer your questions there, but still if I want to solve and tell you that this is how this problem is, it's little difficult to communicate things like that. General queries we can attend there, so please join Tuesday's session and ask your doubts. Please solve by yourself and show us what you have solved and in which step you got stuck, and we are always there to help you. Okay, this session is especially for addressing the discourse issues because few questions have not been answered there. So I want to answer each questions quickly. So whoever has similar doubts, please stick to it. Okay. Some one student have asked that question 7 in GA1 graded assignment 1, I had selected frictional force as a disturbance in addition to uphill downhill. So I'll just share my screen. Okay. So I hope it is visible. Fine. Now, question GA1 or question 7. Graded assignment 1, question 7, what it is. In a cruise control system in a car, which of the following can access a disturbance? So he was asking uphill, downhill, along with that. He thought the frictional force will also be there, but it is not in the options. Why it is so? So disturbance, we consider it's generally as a external factor. In the question, what can be accessed a disturbance is the actual question, right? So what can affect the car from external things externally, what parameters can affect the car's internal dynamics? That's what the question is. The frictional force is always considered to be the part of the system load. You can ask, he again asked that friction can be based on the different types of roads, right? Yeah, it depends on different types of road. Again, we consider that as a part of the system transfer function or system state equations. So whatever the road is, this frictional force will be the part of the system. So based on the road's nature, this frictional force constant will change in the system part. It is not considered to be very random. We know whether we are going to drive a vehicle in asphalt or ice or over any different terrain, right? So based on the terrain, we can fix the constant. That's what thing is. There are vehicles like on-road vehicles, off-road vehicles. So whatever we defined or whatever we are defining a system for on-road vehicles, the frictional constants will be constant or it may change based on the way you are going to drive. But it is not always depends on the external force that keeps changing randomly that we cannot fix. For example, wind speed. So we don't, the wind speed cannot be dependent on the vehicle speed, right? Based on your vehicle also it changes, but still wind's nature is different from whatever we have. So that will be the disturbance. That's how the frictional force is not the part of the option. So if the student who asked this question, if you are a part of this discussion or now if you are in the live session, please let me know if you are okay with this answer. Otherwise, I can explain it further. Or you can discuss that in the discourse also, no problem. Okay. Okay. I'll come to this part because I will explain this in my by drawing that in my from a notebook. Okay. Okay. Same. I will explain that. Yeah. Somebody has pointed out that there is a mistake in this presentation. Yeah, it's supposed to be V by R, I equal to V by R. By mistake, it was given like this. We will correct this in the presentation. And somebody asked question in this Q2 PA3, practice assignment 3, question 2. Practice assignment 3, question 2. Okay. Right. A linear system initially at rest, so this will be initial condition is equal to 0, is subjected to an input signal. So R of t is 1 minus e power minus t is your input to the system, and the response of the system in time domain they have given. So instead of C of s, here it was mentioned as C of t. So the first thing is convert both to a Laplace domain, R of t to R of s and C of t to C of s. So if I convert this to a Laplace domain, I would get for one, this will be 1 by s plus 1, right? And this will be 1 by s plus 2. So you will get R of s by C of s. And the question is, what is the transfer function of the system? So transfer function is the Laplace of output by input. Here output is C of s, input is R of s. So Laplace of C of t divided by Laplace of R of t. That gives you C of s by R of s. So if you find the Laplace for individual and put it as C of s by R of s, you will get the transfer function. So I'll explain the steps here. Input signal is this, right? So if you take a Laplace, 1 by s minus 1 by s plus 1 will come. Instead of e power minus t2 2t, it will be 1 by s plus 2. Here it is 1 by s plus 1, here it is 1 by s plus 2. If I put both in a CFS by RFS format, I would get some expression like this. So the overall expression will be 2 into s plus 1 by s plus 2. Here is where everybody is making mistake, how to convert the denominator to numerator. So if you know the format, right? A by B by C by D is equal to A by B into D by C. So that's how this comes. Right? The answer is 2s plus 1 divided by s plus 2. If you have any doubt, please pass me and ask your questions. I hope everybody is with me. Okay. Okay. For this question, week 4 GA, question 4, 5, you have done. Okay. I'll come back to you. Okay. Please wait until I finish this. Practice assignment 1, question 4. So, which of the following is a linear system? It was asked here. Actually, the answer is none of the above here because why the A option, even it seems to be linear, we have all studied this y equal to mx plus c as a linear one, but still it is under non-linear options. Somebody has this doubt. If you see a linear system, it always passes through the origin. If you see a y equal to mx plus c format, even though the m is 0, if the c is non-zero, it won't start with the origin. So it can start anywhere and it need not to be linear. That's why y equal to mx is linear while y equal to mx plus c is not linear. Okay, rest of the things it's visibly non-linear. So the correct option is none of the above. Okay. For this question also the answer is wrong. I can solve this in my notebook and show you what is a proper answer. Okay, we will do this. Okay, error answer. Okay, next question. Week 2 control engineering. Okay, this also I'll solve. These are all the things I couldn't solve and tell. This is how the steps comes in the discourse. This is both the questions are same here. It was given like both are underdamped system. It was mentioned. One is undamped, another one is underdamped. We'll change that questions. You won't lose marks for this. Um, Live session I have updated. PU2 Q6 wrong. PU2 Q6. Practice assignment to group question 6. Okay, we'll solve this also. And okay, fine. We will solve address this. Week 2, lecture 3. There are some audio issues, so we have explained it in the live session. If you couldn't understand that part, please let us know. We will do a session on that. YouTube link I have updated. And what is the relationship between Laplace and convolution? Somebody has asked. So the both are a mathematical representation we use in different occasions. For example, convolution in time domain will look like y equal to x into h, right? So that we can write as x of tau, h of tau minus t d tau. While in Laplace, it's not convolution. You don't have to go through all these things. It's just a multiplication. So you can use both, but Laplace is more convenient if you are okay with changing from one domain to another domain, like time domain to S domain. That's it. You can change it back to time domain again. I would prefer doing that instead of doing time domain calculations in convolution. But why do we have all these things is this kind of properties makes solving the LTI systems very easy. Linear time invariant systems very easy, right? That's why we are using all these things. This is a basic difference between convolution and Laplace. Okay, fine. Now we will solve few problems. Somebody has asked this in the group, some messages. Okay. Week 4, question 4, 5 have doubt. Question 4 and 5. What is the summation date? 8th. Okay, fine. 4 and 5 you have doubt. Okay, we'll solve this. Okay, fine. I'll solve one by one. And this will be a practice for your quiz also. And we will solve few problems for quizzes. And we'll discuss what to expect, what not. GA3 question 6, 7, 8. Okay, fine. Revision session we are doing for quiz one. Today could be the revision. Tomorrow, the Thursday session also we can revise the questions. Okay, sorry, one by one. First question is from GA3, 6 to 8, I think. Oh, 6 to 8. Okay, fine. This little typical problem where you will see if you use the logic properly, then it's very simple one. So summation, and this is the forward s plus 2. This is another summation. This is u2. Okay, there is another thing here. 1 by s minus 1. Okay, fine. So in general, how we used to think is, if I have a system and this is input and output, this is considered to be the open loop system without any feedback loop. Another way to represent the same system is system, but I'm giving back the feedback from some sensors or something. So the same input and same output, but my output depends on the my input to the system here depends on my output nature of my output. So if I want to tune according to my output, I will be able to do in closed loop system that I couldn't do in the open loop system. Here always this seems to be a feed forward network and this seems to be the feedback network. This is how we have picture in mind, if whatever the closed loop system is. What if I slightly change this? Now, how do you think about this? What could be the feedback and what could be the feed forward? Will it be same? Feed forward, feedback? Is it right? No, right? Because even though it's pointing outward, here this is the input and this is going to be the output. So from input to output, if we are connecting something, then this should be the feedback. This should be the feed forward network. Based on where you are giving the input, the network's dynamics changes. That's how this question is being framed. For example, for the same system, for the same system, if I have, oh, if I consider U1, then this is going to be 0. If I consider U1, one of the input, then this is going to be 0. This is feed forward. This is feedback for case 1. If I consider this as an input, y U2 as an input, then this is going to be 0. So this becomes feed forward and this becomes feedback. That's how your transfer function is going to change. Right. In the question 6, it was asked, complete the transfer function from U1 to Y. If it is not a multi-input, multi-output system, generally whatever input the transfer function has been asked, the other inputs will be considered to be 0 while writing the transfer function, because transfer function always been written in 0 initial conditions, right? There will not be any other inputs except the one you are considering for writing the transfer function. Now, when you consider U1 to Y, this is going to be the flow. only this, right? So how will you write a closed loop transfer function? Y of s divided by u1 of s is equal to g divided by 1 plus gh, right? Here this is g, this is h. So it is going to be s minus 1 by s plus 2 divided by 1 plus s minus 1 by s plus 2 into 1 by s minus 1. This 2 will get cancelled. S minus 1 by s plus 2 divided by 1 by s plus 2. Sorry. 1 plus 1 by s plus 2. S minus 1 by s plus 2 divided by s plus 2 plus 1 divided by s plus 2. So this will get cancelled. So s minus 1 by s plus 3 is going to be your y of s divided by u1 of s. Sixth question is over.
Ma'am,
Seventh, yeah.
when we will write that y is by that output by input equal to gh by 1 plus gh.
It's for negative feedback system. So here your system has negative feedback, right? Here your system has negative feedback. So whenever you have a negative feedback, the transfer function becomes feed forward input. Maybe I will call this as R of t for ease of access. And there is G, H, and this is going to be the output. C of t, either you can take it out here or you can give it back here. So this is plus, this is negative. So based on the sign of this, your transfer function will change. Another combination could be R of t, G, H, plus plus. So this is the positive feedback system, that is a negative feedback system. So what is the difference between these two? So your transfer function here would be in Laplace domain, C of s divided by R of s is equal to G of s divided by 1 plus G of s into H of s. So here plus will come. Okay. C of s by R of s equal to G of s divided by 1 minus G of s into H of s. You can see this derivation in the presentation. Here minus will come. So if you have a negative feedback system, your transfer function will look like this. There is a positive here. If you have a positive feedback system, you will have a negative here. But the most widely used combination will be this in control system. This will be used only in oscillators, positive feedback. We are not bothered about positive feedback. We don't want any positive feedback system because it keeps oscillating. It won't settle. The output will be mostly like this. It won't settle. So based on the nature of the system, it may settle, may not settle here. So this is more interesting thing to design a control than this system, right? There is nothing we can do about this. So we mostly use negative feedback system in our course. So the transfer function you are going to use is this, right? GFS by 1 plus GFS into RH. That's why I have used this. I hope this is clear. So for the seventh question, compute transfer function from U2 to Y. They have asked for the same system. What is the same system here? S minus 1 by S plus 2 y 1 by s minus 1 plus minus plus, right, this is minus, this is plus, and it is u2. So now what we are going to do, we are going to make this y1, nullify this y1 because we don't want this y1 since it has been asked from u2 to y. u2 to y, how it goes? Input, and it goes like this. So this will become a feed forward. This will become feedback. So this is G now. This is H now. Remember, there is no input here. Okay. So this is the negative feedback that you usually see here, right? It's just inverted. If you just invert your notebook, then you will be able to visualize this properly. Now, what is G? 1 by S minus 1. H become S minus 1 by S plus 2. Same transfer function. So, U2, how will we write the transfer function? U of S divided by U2 of S equal to G of S by 1 plus G of S into H of S, where only G and H are interchanged here. So what is G? 1 by S minus 1 divided by 1 plus 1 by S minus 1 into S minus 1 by S plus 2. Both S minus 1 will get cancelled. S minus 1 divided by 1 by 1 plus 1 by S plus 2. This is again be S minus 1 divided by S plus 2 plus 1 by S plus 2. So this will become S minus 1 by, sorry, 1 by S minus 1 by S plus 3 by S plus 2. This both will come same. So S plus 3 divided by S minus 1 into S plus 2. I hope this is correct. Location of 0. No. Somewhere I made mistake while inverting. Give me a minute. I'll check.
Hello, ma'am.
Yeah, yeah.
It should be s plus 2 upon s minus 1 into s plus 3 in last step.
This one,
Last step.
last step.
Yeah.
It should
It
be S. Uh,
s plus 2 upon s minus 1 into s plus 3
S plus 2 upon S plus 3 it should be.
into s minus 1.
Into?
S minus 1 in the denominator.
Okay, let me figure out. Please give me 1 minute. Where I made mistake, that should be known, right?
See the second last step and last step.
Here
Yeah.
should be S plus 2 divided by. Okay, okay. You are telling like this. S plus 2 divided by S minus 1 plus S plus 3. Is it right?
Yes, ma'am, right.
Okay, fine. Thanks. Okay, fine. Now we'll solve next question quickly. We don't have time. Only half an hour. So next question, J3. This was Q2, PA3 was addressed. PA1, Q4 was also addressed. Okay. This question, GA2, Q11. Okay, GA2, Q11. The question is Q11.
Ma'am, question 12.
This is question 12.
GA2 question 12.
Question 12 it is there. Okay. It's because of the first question they have included. Okay. dt square plus 5 dy of t by dt plus 6y of t equal to 3 dx by dt plus 2x of t. So for solving, uh, before doing this, I want to differentiate two things. The questions in quiz can be like this. So we will give a differential equation. Like this is the differential equations. And we will ask you to find the Laplace of this. This is one type of question. Another question that can be little more, that can have little more marks. We will give the differential equation, but we will ask you to find the final value of this. This is another type of questions. So for everything, you have to go through the same steps. First, whatever differential equation you have given with, you have to find the transfer function of the differential equation. How we will do that? If you know one formula, you will be able to do that. What is that? D power n y of t divided by dt power n is equal to, how it will start? S power n y of s minus y of 0. This is the first initial condition. Minus y dash of 0 until y power n minus 1 dash. So I don't know how to write this. This many differentiation it has to be done. If it is d square, y dash is enough. If it is d cube, y double dash should be enough. Kind of that. Okay. Again, plus s power n minus 1 y of s minus. Similarly, it will go on until you go to s power 0. That is it s power 1 generally. That is equal to whatever value that is. Okay. If this is confusing, we'll solve problems. It will be easy to understand, right? Now, the question has been asked for dyt divided by dt square. We'll solve one by one. First, how can we write this? S square y of s minus y 0 minus y dash of 0 plus s y of s minus y dash plus, no, this is that's it. Oh, okay, right? Any doubt in this? This y of 0 will change based on the, oh, it got stuck. Yeah. 1 minute, it got stuck. I don't know why. Okay. Right. In general, this y of 0 will be the initial condition which will be given in the question. If it is not, consider it to be 0 always. Okay. Now we are going to consider it to be 0 because we don't have any, oh, it is given assuming 0 initial condition. So whatever the differentiation is, consider everything to be 0. We don't have to bother about it. So now we will be left with only this a square term. The next term is phi dy by dt. This is s into y of s. Rest of the terms are 0. All the terms, whatever it comes. Then the next step is 6 y of t. So this is just 6 into y of s. That's it. The right hand side is 3 dx by dt. This will be again s square, but please be careful whatever variables you are using. Okay. So since it is x, this will be s square into x of s. By mistake, if you put y of s, the entire problem will be wrong. So rest of the things are 0. All the initial conditions are 0. Then 2x of s. Sorry, 2x of t. This will be 2 into just x of s. So this is output and this side is the input side. Now we are going to write it as it is given in the question. So this will be s square y of s plus or minus plus everything plus 5 into y of s, 5s into y of s plus 6y of s equal to s square x of s minus It's plus again 2 x of s. So you have this. Now taking y of s common, this will be s square plus 5s plus 6.
3x, 3s square x is
Uh, 3 is there. Oh, 3 is there. Okay, thanks. So it will be x of s into 3s square plus 2. Sorry, again, it is x. It's only dx by dt, right? It's not x by x. It is x. S into x. 3s plus 2. That's it. Fine. Now, Laplace transform. How the transfer function will be written? Laplace of output by Laplace of input at zero initial conditions. Already we consider zero initial conditions. It will be y of s by x of s equal to 3s plus 2 divided by s square plus 5s plus 6. Now, how can we write this? We are going to factorize it in order to find the final value. So, how to factorize this? Can I write this as 3s plus 2 divided by s plus 2 into s plus 3, 6 and 5. Okay, it will come. Fine. Now, if I factorize this, what I will get? Oh, one more thing we forgot that they have given x of t, right? We just
yes, ma'am.
ignored it. Okay, that is the important part. So here x of t is equal to e power minus t u of t. So we have to consider that also, right? So here x of t is important. So x of t equal to e power minus t u of t. Then x of s becomes 1 by s plus 1. So wherever x of s is there, you have to substitute this to 1 by s plus 1, right? So along with this, another 1 by s plus 1 will also come. The entire transfer function will be s plus 1, s plus 2, s plus 3. It's a little lengthier one. So how will you take partial derivatives of this? 3s plus 1, 2 equal to a by s plus 1 plus b by s plus 2. So this will give me a into s plus 2, s plus I, s plus 2 into s plus 3 plus b into s plus 1 into s plus 3 plus c into s plus 1 into s plus 2. So considering s is equal to minus 2, maybe minus 3 first. Oh no, I want to find the a first. So considering s is equal to minus 1 first, then it will a into 1 is into 2 equal to minus 3 plus 2 minus 1, right? So if I make any mistake, please let me know. So a equal to minus 1 by 2. If anyone needs any help in this partial fraction, that also please let me know. I will slow down. Considering s is equal to minus 2. So I want to find b. So if I put minus 2, these both will go to 0. No, that's why I'm putting s is equal to minus 2. So this will give me b into minus 1, 1 shall be equal to minus 6 plus 2 minus 4. So b equal to 1 by 4. S equal to minus 3 would give me c. Minus 3 becomes
b equal to 4 होगा.
b. B equal to, b equal to 4. Yeah. I'm bringing 1 here, right? So b equal to 4, right, right. So s is equal to minus 3 will give me c into minus 2, minus 1, minus 3, minus 9 plus 2, minus 7. So this will be c equal to minus 2, c equal to minus 7, c equal to minus 7 by 2, right? Okay, now I have each terms. So this will become 1 minus 1 by 2 by s plus 1 plus 4 by s plus 2 minus 7 by 2 by s plus 3. This is your C of s divided by, no, y of s divided by x of s. Because x of s we already multiplied it here. So only y of s will be there. This x of s already gone here, right? We have multiplied it. So this will give me minus 1 by 2 e power minus t plus 4 into e power minus 2t minus 7 by 2 into e power minus 3t. So this is your final answer. Now, this is one type of question I told, no? Second type is, we will tell you, I'm going to find the output value. This is y of t. Please find this is y of s, y of s, this is y of t, because we have converted back from Laplace to time domain. Now the other question is, I can ask at t equal to zero point 0.5 seconds, what is my y of t? So in this case, you will just substitute minus 1 by 2 e power minus zero point 0.5 plus 4 into e power minus 2 into zero point 0.5 minus 7 by 2 into e power minus 3 into zero point 0.5. So this is going to be your y of t. This is the final answer. This will be given in your choose the best answer or a fill in the blanks. So for finding two types of this question, you have to follow all the steps. Any doubts so far? If no, we can move forward to next question.
Ma'am,
Yeah.
can you scroll down?
Okay.
Uh, more, more. Yes, ma'am. Then the value of the value of 3dxt upon dt is equal to 3s square x of s.
Yeah, this is d squared y by dt square plus 5 dy by dt plus 6y equal to 3 dx by dt plus 2x.
Uh,
That's why we have written like this.
Write down 3x 3x upon dt.
Ah,
You wrote the value 3s x of s. I think here is s square.
where is x square?
The value of 3x, 3dxt of dt.
Previously I wrote s square by mistake, but I changed it. If you have noted it down like s square, it is a mistake.
Oh,
It's actually yes, because it's one differentiation only, no 1 degree differentiation. If it is d squared x by dt squared, then it is 3s squared. I made a mistake initially. Please note it. Okay. Clear?
yeah.
Okay, fine. Now we'll solve some other question. Okay, this is the same question another students have asked, and he has solved correctly only. So if you are seeing this session, it's right. Mm, mm, mm. Yeah. Am I missing anything? Another question I've been. Okay, I noted it down. I couldn't find it in this course. I'll solve it here. But it is there in the questions. So this is a similar question. This is d square y by dt square plus 7 dy by dt plus 6y of t equal to 3 into x of t, where x of t was given as delta t. Similar question, same thing. So similarly, assume zero initial conditions. So this will be yes 2 into s square, because this is second order term. This is second order term. So s square into y of s plus 7. S into first order term. So s into y of s plus 6. There is no differentiation. So y of s as it is equal to 3 into x of s, where x of t is equal to delta of t. This is called as impulse function. So delta of t, Laplace of delta of t is equal to 1. So it's just 3. So this will be 2s square plus 7s plus 6 into y of s equal to just 3. So y of s equal to 3 by 2s square plus 7s plus 6. So this is going to be a transfer function. So how can you, okay, just do partial fraction and you will get the answer. Okay. There is nothing formula or any technical thing here. Just do partial fraction. It will take time if we do now. Partial fraction, whatever fractions you get, if you calculate it correctly, you will get the transfer function. That is the right answer. Okay. I hope I have covered most of the questions in discourse. If you still have doubts, please put it in discourse itself. We'll discuss it again. And let me just go through the quiz concepts once. I'll open the topics. So quiz 1 covers, when is quiz 1? March 15 or 12?
Man, 15.
15. Okay. So this will cover content from week 1 to week 4. So in week 1 to week 4, the question mode of questions would be mostly MSQs, MCQs, short answers. It may be based on true or false. Not true or false, really. It's just a numeric answer, NAT, numeric answer type. And there's might be true or false also. It is also considered to be a MCQ only. So these are all the things, and you may also expect a comprehensive question where 2 or 3 questions will be clubbed together, and that types also comes under these things. For example, one MCQ, one MSQ, one short answer kind of. This can be considered as a one question with the same data. It's common data question. Okay, this is going to be the pattern of your quiz, and total marks will be 30. Maybe 50 minutes will be given, I think. 50 to 1 hour. I'm not sure about it. Within 1 hour, it will be. Okay. And computer based everything. There is no need to solve and submit any answers. And week one is mostly the introduction to the systems, where we would have seen some of the basic applications like mechanical systems, rotational systems, translational systems, or electrical systems like RLC circuit, RC circuits, kind of. And slowly, from the end of week 1 to week 2, we started introducing transfer functions, how to represent a system, that is the Laplace of output by Laplace of input. And then from week 2 to week 3, we would have covered, maybe I have jumped few things, but it's going to be same. We would have introduced the Laplace transforms. I think week 2 covers convolutions also, right? Convolution and Laplace transform. Then maybe we would have come to the transfer function. Then week 4 broadly covers time domain analysis. So in time domain analysis, there are two major things: time domain specifications like TP, TR, TD, MP percentage. If you know all these formulas, then you will be able to crack all these questions, right? There is no logical questions here. And you should know the relationship between each and every specifications. If I increase the MP, how my rise time would be, how my settling time would be. So TS will also be there. The next important part is the steady state part. So for the steady state part, please go through the table. Please don't memorize the table. That is step. Next one is what is step parabolic. No, ramp, parabolic, And here it will be type 0, type 1, type 2. So how this table? So based on this table and the final value theorem will be your savior. So based on these two, you will be able to answer this steady state error based question. What is steady state error? We have seen last time, right? If this is supposed to settle at a set point, but if the system stops at somewhere here or maybe stopped us somewhere here, the difference between the actual set point and the final value is going to be your steady state error. Based on this, we might ask directly, given the system final value, what is the steady state error? Or given the steady state error, what is the type of the system? So these are some interconnected questions that we have solved last week, I think. Based on that, you would expect some questions. Apart from this, please prepare system representation. So we might ask giving this. It's a series RLC circuit, right? So this is I. You should be able to write the transfer function out of this. Maybe write the transfer function, or maybe write the differential equation, then transfer function, then the final value as we solve right now. Y of t at t equal to zero point 0.1 might be asked this kind of question. Similarly, if this is electrical, maybe a mechanical systems like spring damper system. How do we write it? And a damper system, right? So this type of question will also be asked. So if you see closely, these both systems are same, irrespective of their parameters. If you write the transfer function for this, you would get the same parameter s square, some a square plus b s plus c, some above. Here it is going to be some ms square plus bs plus k. So both are same. That's why this knowledge of transfer function will not be enough. Will not be enough to identify the entire system. It is enough to know whether the system is oscillatory, whether the system has steady state error, or what is its peak value, or how it's behaving, whether it is underdamped, undamped, or overdamped system. This type of understandings can be done from the transfer function. But if I just replace a similar system which has same characteristics, you would not be able to differentiate from the transfer function whether it is a mechanical system or electrical system. So this is the basic difference. Maybe I can say the another characteristics of a transfer function. So these are some beauty nuances you can wonder about it. Please prepare this for the quiz exams. How if I have been given with a system, how I'm going to write a transfer function out of it, or to find the final value out of it. Preparing this concepts. Rest, maybe prepare some basics of convolutions, Laplace. I don't know why this is happening. Let me just close it and open it. Convolution and Laplace transform is essential. So in Laplace transform, study differential equations to Laplace as we transfer function as we did today. S square y of s formula. What else that is important? E power general Laplace transform formulas. Let's take. So if I write e power at, what would be that? And cos t, sin t based on that. It will be for cos t, it will be s by s square plus a square cos a t it is, right? So if it is sin bt, it will be b by s square plus b square. So what if e power minus at cos bt would come? So this will be s plus a divided by s plus a the whole square plus b square. Similarly, e power at sin bt would be s plus, sorry, not s. b by s plus a the whole square plus b square. So if you are given with this kind of transfer function and ask you to find the time domain of this, you can just simply apply this formula to find it out. You don't have to do it step by step from the scratch, right? So please go through all these formulas, shorthand notations, how to go from one domain to another domain. This can be essential. And that's it. Mostly, if you cover this, you'll be able to score well. Let me give you some 2 or 3 problems so that you'll get some more understanding about it. Final value theorem, initial value theorems. These are important in Laplace transform test. Quick question. What is the Laplace transform of t power 5? Put it in the chat box, whoever is attending. I can consider this for the success test. P3Q1. I will explain. Please type it quickly. Don't take time to find it in the browser. I don't see any answers here. There is nothing to solve it here, right? Base power 5, is it? Is it so? And 20 by s power 6. Rest of the people, which of the answers do you think is correct? Yeah. Okay. Rest. Abhay Pal, Divyanshu, Soma, Yash Kumar, Priya. Please answer quickly. Nikhil, type it in the chat box. Okay. Everybody answer. I'm going to close it now. By 6 to, I'm going to stop it. I won't consider after that. Okay. Sorry. Okay, fine. So t power n, the Laplace transform of this is n factorial divided by t power n plus 1. So n factorial is 5 factorial divided by t power 5 plus 1. It is 5 factorial by t power 6. So 5 factorial will be 5 into 4 into 3 into 2. This will give me 20, 60, 120 divided by t power 6. Both are right. This is also right. This is also right. Good. Okay. What is the this I'm solving for you? Laplace transform of e power minus t minus, oh sorry, t minus 2 u of t minus 2. It's little confusing, right? So Laplace of e power minus t into t minus 2 into u of t minus 2. So how can we write this? I am going to,
I'm taking t minus 2 another way, that is, or a or b, if we take.
so we can write it as e power minus 2, Laplace of e power minus t minus 2 into t minus 2 as it is into u of t minus 2. Because this is, I'm writing this into e power minus 2 into e power plus 2. So both are same, right? Both will get cancelled. So e power minus 2 I'm putting outside and e power plus 2 I'm putting outside. Minus into minus plus. So that I will get the same kind of expression inside. That's why. So e power minus 2 will come. So how can we put this as a equation? Do you remember any property that will solve this easily? Into t of 2. Any property do you remember, like time shifting property? Please go through this so you can answer it properly during your quiz. So this is easy way to represent this kind of system. For example, e power minus t minus a into t minus a, I can write it in terms of e power minus as into Laplace of e power minus t into t u of t. So this will give me e power minus 2 into Laplace of, okay, it's little complicated here because you know Laplace of, if Laplace of e power minus t, we know that is 1 by s plus 1. So Laplace of t into e power minus t, how it will be? 1 by s plus 1 the whole square. So that's how it is. U of t is 1. It's unit step, right? So we are leaving that as it is. So 1 by s plus 1 the whole square. So if it is Laplace of t power n e power minus t, this is going to be 1 by s plus 1 the whole power n plus 1, right? So if it is 1, here it is 2. So it is n plus 1. So this is e power minus 2 into s plus 1. I can write it like this, into 1 by s plus 1 the whole square. Laplace won't come here because I have already taken Laplace, right? So only this. This is your answer. So please go through the properties of Laplace transform. So you'll be able to answer this kind of questions. Similar questions can come in Laplace transform as we solved before, differential equation into that. Convolution theorem, apply convolution theorem and practice, and practice systems to transfer function. I'll solve one more question in the week 4 and we will wrap up. Already solved these questions. Okay. Maybe I'll start with the larger question. Statement 1, I'm making. For a second order system, maybe closed loop transfer function. For a second order closed loop stable system, CL is closed loop stable system, TS is inversely proportional to the damping ratio. This is the statement 1. Statement 2 would be, for a closed loop second order stable system, same system, peak overshoot decreases with increase in damping ratio. Which statement do you think right? Or both right? Or none of the statements are right? What is your what is your opinion about it? Can you please quickly type S1, S2? Which do you think correct? Just type that. If nothing you think is correct, type 0. Or S1, S2, or S1 alone, S2 alone. Statement 1 is for a second order closed loop stable system, settling time is inversely proportional to its damping ratio. Statement 2, for the same second order stable closed loop system here, okay? And overshoot percentages decreases with the increase in damping ratio. What is the equation for settling time? 4 by zeta omega n.
Yes, ma'am.
How the damping ratio will be there for a system? It's omega n square divided by s square plus 2 zeta omega n plus omega n square. So for this system, for the same system, consider zeta equal to 0 and zeta equal to 1, and then put this in a settling time and find whether both are correct or not. And for the overshoot, the same zeta will be there in e power minus zeta pi divided by 1 minus zeta square. We already did this, if you remember. Somebody put S1 alone correct. Meanwhile, I'll write the other question. Please answer it in the chat box, okay? We are overshooting time, so I'll just quickly find solve this. Meanwhile, type your answers. What do you think? Please don't wait for others to answer. Just type what do you think. Okay. Okay, fine. We'll come back to that later. Unit step input. One unit step input is applied to a unity feedback system. That is like this. This feedback is 1. Just 1 here. And there is an input here. It's a negative feedback system. In general system, we used to consider G divided by 1 plus G of s into H of s. Okay, it's in a steady state error. It has a steady state error of 0.05. So the ESS here is 0.05. If you think this is a finite value. The question is, what is the type of the system? The second question is, what is the positional error constant? If you remember the table properly, you will be able to answer this. The question is given step input, and there should be something type 0, type 1, type 2. So for which type of system, the step input, if applied, will give a finite answer. If it's a type 0 or type 1. This is finite. If this is right, then it's type 0. Then what will come here? What will come here? Okay, it's type 0 system. I think you are not confident enough in this concept. Please sit and go through this table and then try solving it by yourself. Okay, nobody is answering this. 1 plus kp. This is the uh, formula for finding the position error constant with respect to the state error. It was given 0.05 divided by 1 plus kp. So 1 by 1 plus kp equal to 1 by 0.05. So this will give me 1 plus kp equal to 20, kp equal to 90. Okay. Okay. Expect this kind of problems in quiz 1. So we will again discuss few problems in the Thursday session. Okay. If you don't have any doubt, you can give. Meanwhile, if you get
Ma'am,
into
KP is position error constant.
yeah, position error constant. Whenever you apply step, the error can be called as position errors. We saw this in previous session. If you
Um,
apply ramp, it is called as velocity error constant. So the relation between ESS between
when it is written as steady state error only, then it will be ESS only, na?
ESS only. ESS is steady state error.
Yes, ma'am.
So this is the difference between sorry relation between ESS and position error constant, ESS and velocity error constant when applying step, when applying ramp, when applying parabola. It's 1 by K acceleration error constant. This one only this will have the formula of 1 by 1 plus Kp. Rest are just inversely proportional. Okay. You can leave if you don't have any doubts. It's already 15 minutes more. Okay, I'm sorry. I told that we can discuss that question, right? I'll revisit it. Please be there for some time. Anyway, this is being recorded. Whoever has left can see the recorded session. What is week 5? Sorry, week 4, G5, question number. Okay, fine. 1 minute. Let me open it. PA3 Q1 also. Okay, fine. We'll discuss. Okay, the question is it's common data for 4 and 5, right? Am I presenting the screen? No.
No, ma'am.
No, ma'am.
Screen
Okay.
is not.
It's visible now, right?
Yes, ma'am. Visible.
Okay. The question is the system parameters alpha and k for this GA4 4 to 5. Okay, for the first order system and its response to a step input. It's given in the figure. Okay, first order system, how it generally looks divided by tau this, not zeta, tau is plus a. So where tau is a time constant So it tells when the system is getting settled, and A is the just a tuning parameter here. So they said they are considering some first order system like this, and they are giving this R of t and output as C of t, and the corresponding response to a step input. So if I give the same step input, unit step input that has 1 from 0 to a step input only it was given. Okay, let us consider unit, and if it doesn't satisfy the results, we'll change mode. Okay, this is C of t. This is t. C of t represents the output. So the system gives some response like this. One is this, another response is this. Okay, right. I couldn't see the comments. Wait. Okay, right. So this is the system. So first order system, they are giving step input, and this is the response we got, that is C of t. The question is, for this system, the value of alpha. So here they have used this k divided by s plus alpha, where tau is equal to 1, time constant is 1, and they are just asking what is the value of alpha. How do you find alpha from, from this response? That is the question. The first question is, according to the first question, we usually have a step response that looks like this, and it's eventually settled, right? So for this to happen, the system should be underdamped. Then only the system will, the response will get settled, right? So here you get the unsettled value and the settled value, both you will get. So the system should be underdamped to exhibit an overshoot. So there are overshoots. So for this, you are going to consider, if this is a underdamped system, then the zeta value will look something like this, right? How do you solve this? Stability value of alpha they're asking here. Okay, fine. It need not to be underdamped. Okay, wait. Because this overshoots and it is not settled, right? So you cannot consider that assumptions. Okay, let me solve it this way. Consider this to be the your first order transfer function, right? So your R of s is equal to 2. So if it was given as step input, response to as step input was not mentioned unity, because here they have given 2. So you have 2 into u of t is your R of t. So if this is your u of t, R of s will be 2 by s. C of s, C of s by R of s, already given k by s plus alpha. So C of s can be found as k by s plus alpha into 2 by s. So we can do a partial fraction. A by s plus 1 by s plus alpha will be equal to 2k, right? So this will give me, uh, when a equal to 0, sorry, b by, right? A into s plus alpha plus b into s equal to 2k. So when s is equal to minus alpha b equal to 2k, b equal to 2 minus 2k by alpha. If I make any mistake, let me know. When considering s is equal to 0, alpha a equal to 2k, a would be 2k by, again, 2k by alpha. So my transfer function in time domain would look something like this. So far, I think I'm right.
Yes, ma'am, right.
Minus b2k by alpha by s plus alpha. So this is going to be your transfer function, C of s, right? So now, if you take a inverse Laplace transform of this, you would get 2k by alpha into e power minus, no, 1. It's not e power minus t, e power minus 0, it is 1 minus 2k by alpha into e power minus alpha t is going to be your transfer function, right? So how can I write this? 2k by alpha into 1 minus e power minus alpha t. That is right. So the steady state value, it was given here. It's not error. So I can write it as steady state value. How to find a steady state value here? This is supposed to be your steady state value. 2 is supposed to be your steady state value. So how to write this at infinity? So C of S can be at infinity. S tends to infinity. This will be C of infinity. It is also written as C of t by t tends to infinity. So when I put t equal to infinity here, when t tends to infinity, so this is a little clumsy problem. We have to try to derive the values from your known relationship. The only relationship we know from the figure is the transfer function. That's why we are doing all these steps. So when t tends to infinity, this will become 2k by alpha into 1 minus e power minus infinity. E power minus infinity is 0, I guess. So it will be 2k by alpha, 1 minus 0 into 2k by alpha. So your C of t is just the 2k by alpha, right? Have I done any mistake here? It's right. Now we want to know the alpha value without having any other information. So for that, I'm going to know at what steps this, how the C of t is going to propagate. How to know that from one step t equal to 0 to t equal to 1. If I want to know what I have to do, I have to differentiate it to find the trajectory values. That's why I'm going to differentiate C of t. So dc of t divided by dt. What is C of t? This is C of t at t equal to infinity. Don't look this. This is C of t, right? So your C of t is 2k by alpha. Let me write it like this. D by dt of 2k by alpha into 1 minus e power minus alpha t. So if I differentiate this, t is not there. So this is considered to be a constant. 1 is 0. So e power minus alpha t into minus alpha is going to be your c power minus t. So this can again be written as minus 2k alpha divided by alpha into e power minus alpha t. This is alpha, alpha will get cancelled. 2k e power minus alpha t, your c dot of t. So over the period of time, your c of t is going to be like this. So from this, you can find the initial slope. How to find it? At t tends to 0. When t is going to be 0, e power 0, 1, right? So this will be 2k minus 2k you will get. So from the response, you know when t tends to infinity, it is going to be settled at 2. So this t tends to 0, so that s tends to infinity will be equated to 2k equal to 2. Sorry, 2k by alpha, it is equal to 2. Oh, so wait. T tends to infinity is here, right? So 2k by alpha, is going to be 2. K by alpha is equal to 1. From here, when t equal to 0, you know where it is starting, right? How do we know that? When t equal to 0, it's starting at 0. what other information we have? Two is the steady state value. 1 minute. Missing something here.
I'm 0.2.
0.2. Yeah, we can consider that. Let me check it once. I might have missed some information. What is point two here? Okay. Oh, that is the information we are missing here. Okay, we said the point tau is equal to 1 here, right? It's not 1. That's what the wrong assumption I made here. It has to be taken from the image. Since it was not given in the transfer function, I have taken tau is equal to 1. But actually, tau is equal to 0.2 here. What is tau? For a first order system, tau is what? It reaches the value, it reaches the 63 percentage of the final value that we saw why we are calculating 63 percentage, right? It's by 1 minus e power something value we found. So that is the value they have given here. The point two, it's approximately reaching 63 percentage here. That's why this is considered to be tau. So we have to take tau equal to point two. That is the catch of the problem here. Okay. When we take tau equal to point two, where time constant here would be some, if this is alpha, so time constant here would be 1 by alpha, right? It seems to be infinity. 1 by alpha. So if this is 1 by tau is equal to point two equal to 1 by alpha, then alpha is equal to 1 by point two, that is 5. We found 1. And what is the relation between alpha and k here? At infinity, we can say 2k by alpha is equal to 2. So we know this 2k by alpha is equal to 2. When alpha is 5, 2k by 5 equal to 2. 2k equal to 10, sorry, k equal to 5, right? So we found both of this. It's a little lengthy problem. The assumption here is tau is not equal to 1, it's zero point 0.2 because it takes 63 percentage of final value to reach the, sorry, 60 percentage of time to reach the final value. So tau here is 0.2. From that, if you derive this transfer function, you will be able to know the relation between these two. It was clumsy, but I hope it's clear now. Those who asked this question, any doubt in this? Directly, can we use final value theorem in this case? But you cannot find both unknown values, right? Only with final value theorem. That's why we are doing all this. If one is unknown, you can use the final value theorem and find it. Okay, another question has been asked. PA3 Q1 also wants to discuss. We'll do that. Okay, thanks. PA3 Q1. Practice assignment 3 Q1. Okay. This is the MS mechanical system problem. Find the transfer function of each of two mechanical systems given in figure, where x of t represents the input displacement and x naught represents the output displacement. Okay, fine. Now the question is, it's the input x1. There is a damper here, there is a spring here, and another spring that interconnects. This is K1, this is K2, this is called as B, where the input displacement is x1 here. X1 only, right? The another system it was mentioned is B, M. There is no mass in the left hand side system. X naught that acts displacement in this way. So the force will act in the opposite way always, right? And another damper. This okay. The options has the combinations of transfer function for both the systems. X naught by xi. Oh, here it is x naught. This is x1, not I. Okay, fine. Now, for the left hand side system, we will write the equation, differential equation. How would you write a differential equation? Since it is simple, I'm going to write from here. So since K2 is a single connected system, I'm going to write as K2 into x naught of S, because K2 is connected with the x naught, right? Plus K1. K1 is connected in between x naught and x1. So if I am going writing like this, because displacement acts like this, so force, when I write the force equation, it will go from this direction. So first I have written x2 into x naught of S plus k1 into, since I'm going from this direction, this will be x naught minus x1 plus b into d by dt of x naught minus x1, since k1 and k2 are parallel and it is connected in between two displacement x1 and x0. So there is no external force acting, then this equation becomes 0, right? It's instead of, okay, I have mixed up everything here. Let's consider this as x of t so that it will be easy to consider the next step. So x2 into x naught of t, k2 into x naught of t plus k1 into x naught of t minus x1 of t, so that now everything is in the time domain. Now I'm going to consider this into s domain, simply x t into s for simple terms, plus, d by dt, b s term will come, right? X naught of s minus x1 of s, same. Assuming zero initial conditions. So this is your Laplace domain expression of the left hand side images. So now output by input, so x naught by x1. So for that we have to club this together first, right? So how x naught can be separated? K2 plus x. Okay, K2 plus K1 minus again plus BS. That's it for x naught plus x1 into minus K1 minus BS. Anything I missed? Nothing, right? Equal to 0. So now x naught of s divided by x1 of s will be minus K1 minus BS divided by BS plus K1 plus K2. Any mistake I did? One mistake I did. Because everything here is in the same direction, right? If I keep x1 to the next side, for example, if I put minus here, this will become minus. The whole term become minus. So there will not be any minus here, right? So the entire transfer function for first system, left hand side is this. For the right hand side system, which doesn't have any parallel circuits, the transfer function is going to be straightforward. So since I used to write mass first because it has high degree polynomial, so I'm going to write m first. You can also start with b1, no problem. M into this will be d squared x divided by dt squared plus b2. What is there? Okay, this is b1, right? So this is associated with x naught, this is associated with x1. So b2 will be associated with x naught. So dx naught by dt plus b1 is in between x1 and x naught. So b2 is associated with x naught. B1 is in between x1 to x naught. Since I'm writing from down to up, d x naught by dt minus dx1 by dt. There is no force again. So it is 0. So this is again m s square x naught because it is associated with x naught plus b2 s x naught plus b1 s x naught minus b1 s x1 equal to 0. Now separating x naught and x1, ms square plus b2s plus b1 will be equal to b1s into x1. Now again writing x naught by x1, b1s divided by ms square plus b2s plus b. So this is the transfer function. Any doubt in this?
No,
Ma'am,
ma'am.
please explain last equation, that is m
This
this.
one?
So, nee,
This one.
starting, yes, ma'am. Yes, ma'am.
Oh, okay, fine. So the actual system is like this. It was written from top to bottom. I'm just translating it to left to right so that it will be easy to write. Okay. So this is the input. I'm giving x1 as a displacement. This is b1. This is b2. And another x naught is working here. X naught output displacement is happening from the mass. So the mass and other systems are connected to X naught directly, and from mass until the first it is being pushed by the displacement x1. So now how can we write this as? We can split this into two different things. So apart from this, like after this, it will be x naught. Before this, it will be x1. So from this, if I write m is directly associated with x naught. So m into x naught double dot. Why it is double dot? Because in mechanical systems, your mass will produce a force that is proportional to your acceleration, inversely proportional to your acceleration. Not inversely. Wait. I'll explain it later. These are all the parameters in your system, right? So mass, spring is called as K, and damper is called as B. So this is mass, spring, and this is damper, damping, everything is same, B. So what this mass will do is this mass will create a force Fm that is proportional to the negative of the acceleration happens in your system. The spring, this damper will create a force that is proportional to the velocity that is happening, negative of the velocity that is happening in your system. The spring will create a force that is proportional to negative of the displacement that is happening in your system. So how, if x is my displacement, what is my velocity? Dx by dt is my velocity. D squared x by dt is my acceleration, right? So always the damper will provide a force that is negatively proportional to your displacement. Spring will create a force. Confusing things. So spring will create a force that is proportional to your displacement, that is in negative direction. That is more important. And damper will create a force that is proportional to your velocity in negative direction. Mass will create a force that creates a uh, that is in negative of the proportional to your acceleration. That's why whenever you are writing a mass for a force balance equation, you will write in terms of d square x by dt square, that is proportional to the force of the acceleration, right? That's why d square x. Displacement in differentiated twice is acceleration. Whenever you write damping, it will be dx by dt. Whenever you write spin, it will just x, displacement as it is. That's why we wrote like this. Now coming to this system, it has two displacement, right? So the mass is directly connected to x naught. So it is m x naught double dot. That is dx naught by d square x naught by dt square. Plus b2 is again directly connected to the x naught. This will be x naught dot. But b1 is in between x naught to x1. That's why we are writing b1 as, since the displacement in this direction x, the force will be opposite, and that's what we found here, negative of we told, no? So we have to see from this direction. So it is x naught minus x1. If the displacement is like this, we will write a equation from here for force balance equation. Then it will be x1 minus x naught. Okay, this is more important. From where the displacement is flowing, the force you are writing the equation for the force should be in the opposite direction of the displacement. From seeing this, x naught comes first, then x1 comes, right? So I'm subtracting x naught minus x1. Clear?
Yes, ma'am. Now
Okay.
it's clear.
Okay. D square x by dt square plus b2 dx naught by dt plus b1 dx naught by dt minus b1 x1 by dt. So again, you take Laplace transform a square into x naught. Same thing will happen. After this, I think you are clear. We already saw a few
Yes, ma'am.
problems.
Yes, ma'am.
Okay, right. Any other doubts you have? Okay, if not, you can leave. Thank you.
Thank you, ma'am.
Thank you.